Okay, so in this video, I'm going to talk about inverse functions and how to compute an inverse of a given function. So first, let me start with comparing a regular relation and the inverse relation. So then we will define a definition of functions from here. So here I have a relation. So and that is y equal x squared minus 4. So x and y are related by this equation. So I just pick some values for x, starting from -3 and going all the way to 3. And then I just plug each of this x value into the equation for x and compute the corresponding y value. For instance, for the first one here, I pick -3 for x, and I plug it here, so it's -3 squared, which is 9. 9 minus 4 is 5. And I pick -2. -2 squared is 4. 4 minus 4 is 0. And I keep on doing this and generate these points for this relation. And I'm going to plot them now. So -3, 5 is going to be this, -3, 5 is going to be this point right here. -2, 0. X is -2, y is 0. So that's this point right here. -1, 3, that's this point right here. And then 0, -3, that's this point right here. 1, -3, that's this point here. 2, 0 is this point, and 3, 5 is that point right here. So if you just connect those points, you're gonna get this graph for that relation. Now, what the inverse relation is, you're basically switching x and y value. So you're switching these 2 points. So I'm making the y axis and I'm replacing x's with the y. Okay, and they are in this table here, in this table right here. So now I'm gonna plot this. So let's use a different color. So x is 5, y is -3, and that's gonna be this point right here. Okay, that's this point here. 0, -2. So x is 0, y is -2. That's gonna be this point right here. And then -3, -1, that's this point right here. And -4, 0, that's this point right here. -3, 1, x is -3, y is +1, that's this point here. And then 0, 2, that's this point here. And then 5, 3. And 5, 3 is this point up here. So now you're just connecting these dots and you will get inverse graph. So basically blue and red are inverses of each other. Okay, so if you just switch the x and y value, then you get an inverse relation of the given relation, as you see in this example. Okay, so now can we define an inverse relation for any given relation? Well, there is some restriction on that. So let's define that restriction. And there is this particular type of function which we call it one. And for a given function to have an inverse, we require that the function or the relation must have the one-to-one it must satisfy one-to-one relation. So basically, one-to-one relation means that, okay, if I just explain this just on a graph, so let's say take this function here, let's call that. Now I can pick a y value. So let's say I pick a 4 as a y value, and then I can look at the corresponding x value. And if y is 4, then I'll have 4 equal x squared. But then x equal 2 will satisfy this, and x equal -2 will satisfy this. So basically, there will be two corresponding x values. So for one-to-one, we require that one x must correspond to one y value. So there should be a one-to-one relation between x and y. So we can have two different x values mapping onto one y value. So we can have this. So this is not one-to-one. This example that I give you is not one-to-one. So we must have one x value corresponding to exactly one y value. Okay, so then we can say this. We can say that, okay, a function f has an inverse, which we denoted by this notation. F inverse. It's not a reciprocal. It's not 1 over f. It's just a notation. If and only if each horizontal line intersects the graph at most one point. So that means, see, if I had that example, so I'll bring that example again, like this one. If I draw a horizontal line through this graph, and I have two intersection points, and that's why it was not one-to-one. So the definition says that if you draw a horizontal line through the graph, there must be at most one point, one intersection point. Then we say it's one-to-one, therefore it has an inverse. So basically, in order a function to have an inverse, it must be one-to-one. Okay. So most of the times we don't really have to prove this. We don't really have to prove it. So if the question says, okay, go ahead and compute the inverse, then we'll just compute the inverse. We'll assume that the function is one-to-one. So most of the case, we don't really need to prove this this fact. Okay, so I'll just give you maybe a few examples of this, and then we can move on to how to compute inverses. So let's say I take this, let's say y equal to absolute value of x, right? This is a function which has this graph. Okay, this is not one-to-one, clearly, right? Once you know the graph, it's not, because you see you have two intersection points here. So this is not one-to-one. But if I take this function, let's say y equal to x cubed, this function, the graph is like that. And this one is one-to-one, because if I draw a horizontal line through the graph, it's just going to have one intersection point. So this one is one-to-one. Okay, and therefore this will have an inverse without any restriction. But if you have to compute the inverse of the first function, then there must be some restriction with the domain, because this one doesn't have an inverse with this domain. Okay, so, and I'll tell you that as well. So let's take this example. Again, it's not one-to-one, and I'm going to talk about the restriction in this case. So f of x equal, let's say, x squared. Now, the domain of this function, this is a polynomial, and the domain is all real numbers, right? There's no restriction on the x right now, which it has at this graph, so you can easily tell from the graph as well. And this function is not one-to-one, so this current domain is not one-to-one. But if I change to this, I just take this piece right here. This is still y equal to x squared. I didn't change the function, I just changed the domain, which means now I start from 0. So domain of this function will be from 0 to infinity. And now this is one-to-one, and it has an inverse. So as long as function is one-to-one, then it will have an inverse. And I do this cutting. So basically, I just didn't take this piece, right? Or I leave the other piece and take the piece on the left. Doesn't really matter. As long as I don't change the range of the function, I can always put some restriction on the domain so that function can be one-to-one. But the range should not change in that case. Okay. So I should, if I'm going to go ahead and compute the inverse of this function, it has to be in this form, okay, not this one, because this is not one-to-one, not this guy, right? This is not one-to-one. Okay. So now I'll tell you how to compute the inverse. So to find an inverse of a function, given function, we will really just do two steps. So step one, okay, so let me call it step one. Step one is replace each x with y and each y with an x. And then you'll get a new equation, of course. And once you get that new equation, then you will solve the new equation for y. Okay. And then you may want to write it like this. Step 3, you will just write, y equal to f inverse of x for the new one. And that will be the inverse of the function. So it's quite simple, actually. There's going to be a little bit algebra involved here. So let me just show you guys an example. Let's start with this. So let's say x equal 5x minus 3, and we want to find, again, I don't have to really try to prove it's one-to-one, because we're trying to find an inverse, and this is a linear function, and linear functions are straight lines, so they're always one-to-one. Okay, so step 1, now replace each x with y and each y with the x. So this is really just y. F of x means y, right? So I'm going to replace x with y, so it's going to be x equal to 5y minus 3. So this is my new equation. And then what I'm going to do in the second step is solve this for y. And to solve this for y, so I will just go ahead and add 3 to both sides. So this will be x plus 3 equals 5y. And then I'll just divide both sides by 5, which means 5 right here. So I'll get y equal to 3 divided by 5. Now I solve it for y, and since I solve it for y, I have the inverse, so I'll write it like this: f inverse equal to x plus 3 over 5. And when I'm switching x and y, I'm also switching domain and range for both functions, because remember, here I showed you guys in the very beginning, I showed you that to get the inverse relation, you're really just swapping x and y. So therefore, you're just swapping domain and range. So this is if this is the domain of this function, now it becomes the range of the inverse function. This is the range of the original function, and now this is the domain of the original function. So you see, they're interchangeable. Okay, now let me give you guys another example. So let's take this one. Say f of x equal to 2x minus 1 divided by x minus 3. And then I'm going to find, it's a rational function. So let me also write the domain here, because I can at the end write it, domain and range as well. So the domain of this function is, the bottom cannot equal to 0 because this is a rational function. So it will be x minus 3 cannot equal to 0, which means x cannot equal to 3. That's the domain, right? And then the range, we don't know. So it's sometimes for rational function, the range is not very trivial. So let me just leave this right now. And after I compute the inverse, because those are interchangeable, then I maybe easily figure this portion out. Okay, so here's the step 1. Let's start with step 1. We're going to replace x with y and y with the x. So this is going to be x equal to 2y minus 1 over y minus 3. And then step 2, now I'm just solving this for y. So this will be x over 1 equal 2y minus 1, y minus 3, and then cross multiply. If you just cross multiply this, then you'll get x times y minus 3 equal y minus 1, and then distribute the x. So this will be xy minus 3x equals 2y minus 1. Then put the y's on the same side. So this will be xy minus 2y minus 1. So I put the y's on the same side, and I move everything else to the other side. And then I'm factoring y. So this will be, because the point is now we're solving this for y. Okay, then divide both sides by x minus 2. So you get 3x minus 1 over x minus 2. And that's what we call the inverse, right? Okay, perfect. Now I will write the domain of this inverse function. So let me actually go to the next page, and I can do that over there. So here is my original function. And here is my inverse function. And the original one is 2x minus 1 minus 3. And then the inverse function is 3x minus 1. And then the domain here was x cannot equal 3. And the range we didn't know. And the domain here is the bottom cannot equal to 0. So x cannot equal to 2. So now I'm switching it. See, the domain of this becomes the range of this function. So y cannot equal 3. And the domain of the inverse function becomes the range of the original function, y cannot equal 2. You see, I could easily figure out everything I needed once I compute the inverse of the function. Okay, so that's it basically.